Hello everyone, how are you? I am Akrash, your teacher here, and I will teach you different questions and their answers. So I welcome you on classtheta.com. So our today's question is: you will construct a three-dimensional solid out of some cardboard. Answer the question. Describe as best you can what your solid looks like. What cross sections did you see? What familiar solids does it remind you of? Explain your method for calculating its volume. Would you have computed the same volume if you had arranged your cross section differently? Is that you had expect to happen? Explain your method for calculating its volume. Would you have computed the same volume if you had arranged your cross section differently? Is that what you had expect to happen? What did you learn about the volume from this experiment? Making a solid, you will construct a three-dimensional solid out of some cardboard. Answer the question. Describe best you can what solid looks like. What cross section did you use? What familiar solid does it remind you of? Explain your method for calculating its volume. Would you have computed the same volume if you had arranged your cross section differently? Is what you had expect to happen? Explain your method for calculating its volume. Would you have computed the same volume if you had arranged your cross section differently? Is that what you had expect to happen? What did you learn about volume from this experiment? And the answer of the question: for my three-dimensional solid, I constructed a rectangular prism out of cardboard. The cross section I used were rectangles. As the sides of the prism are rectangular, the solid reminds me of familiar object like the shoe box or a book, which are also rectangular prism. To calculate the volume of the solid, I measured the length, width and height of the prism and then multiplied these dimensions together. The formula for volume of a rectangular prism is V is equal to I multiplied by W multiplied by H, where is the length, W is the width and H is the height. If L had arranged the cross section differently, for example, if I had used circular cross section, I would have needed to use a different formula to calculate the volume, such as the formula for the volume of a cylinder. Therefore, I would not have computed the same volume, which is what I would expect to happen because different shapes have different volume formulas. For the experiment I learned for the arrangement of cross section effect, how we calculate the volume of a solid. Different shapes require different volume formulas, and changing the arrangement of cross section changes the overall shape of the solid, thereby impacting its volume calculation. This experiment highlights the importance of understanding the properties of different shape and selecting the appropriate volume formula accordingly. Thank you for watching the video. If you have any question related to this video, please post a comment below. If you have any question in your mind, you can also post on the website and I will be answering you in the next video. Thank you for engaging with us. Until next video, bye bye.